Good morning, everybody. I'm Kristen, and I'm here to talk to you about the concrete repair manual from the point of view of someone who had nothing to do with writing it, but I'm a big fan. My experience with concrete repair is in design, maintenance, and construction. In design, when we're widening a structure, we'll go out and do a condition survey and identify the repairs that are needed, and then we'll put together a plan sheet that'll have these really long lists of general notes. And when a bridge is hit, or a railing or a column, we will help out and put together some sheets for our bridge crew at the San Antonio district or for an emergency maintenance contract. And right now I'm working in the construction office at Bear Metro, and we have two projects where concrete repairs are needed. One of them was damaged by a third party, and the other one was damaged during construction operations. So whether you're in design or construction, this manual is a great help. And you can find it by going to the TxDOT website under Forms and Publications and Online Manuals. A lot of people I found don't know that it's out there and it's available or how easy it is to use. The best thing I think about the manual is that it's short. It's only 52 pages, so it's not a whole lot to read. And the second best thing is you don't even have to read the whole thing. Each section is a standalone document. So you can identify the repair that's needed in Chapter 2. And in Chapter 3, you can pull out the section that you need and take it to the field with you. So it works really well for that. And Chapter 1 is an intro to the manual, and it defines the roles and the responsibilities, definitions, abbreviations, and it references the 2014 standard specs. So I'm going to jump right into the classification of spalls, because spalls are everywhere. I mean, this is the most common damage that we see out there. And the first classification is a minor spall, and that is something that's less than 1 inch deep or less than 12 square inches. And here we have a wing wall that has some damage, and you can see a slight bit of reinforcing steel there, and there's a retaining wall with a spall. The second classification is intermediate spalls. And in this case, you can see the exposed outer reinforcing steel, and there's a max depth about 6 inches on those. And here we have some rail and the underside of an overhang there. No significant stresses are likely to develop due to service loads, but this repair type for these kind of spalls would be to patch with bagged concrete. And I'll go more into the repair methods later in the presentation. Next, we have major spalls, or this is where the damage extends well beyond the outer cage of reinforcement, and significant stresses are likely to develop. Major spalls have more involved concrete repair procedures, and they typically require batched concrete. So we've got minor, intermediate, and major. Now I'm going to go into minor spalls, and I really like the way that the manual is organized, because once you get to the repair procedure, it's organized by a description, then the materials that you need, the procedure, and then it gives you some commentary, which gives you some good guidance there as well. So the first thing you want to do when you're classifying your repair is identify the materials that you need. And for that, you want to go to the DMS 6100 when you're dealing with a minor spall, and that's for epoxies and adhesives. And this is going to provide the type and class of epoxy material and the specifications required. For minor concrete repairs, we're using type 8 epoxies, class A and B. And then there's a nice little link over there that'll take you right to the material producers list, which is great, because that's going to identify which epoxies have already been tested and pre-approved by the department. When you're doing any type of spall repair, surface preparation is vital. You want to remove damaged or loose concrete, socket the perimeter, and avoid doing any damage to the existing reinforcing steel by minimizing the tools that you use to hand tools or a 15-pound max chipping hammer. This is a picture of a spall on the underside of a beam, and that's a close-up picture of it. We use type 8 epoxy mortar, and that's when you combine neat epoxy with aggregate, which is usually silica sand, and you want to follow your manufacturer's instructions when you're mixing. And the manual does give you some guidelines regarding ratios and temperatures. And take careful measurements. You don't ever want to eyeball it. Use a low-speed drill and a jiffy paddle, and add in your materials slowly and set a minimum time. You want to achieve a well-blended and uniform product. If you're using neat epoxy, it should be done on a dry, clean surface, and the material should be brushed, rolled, or scrubbed on so that you fill in the small voids. And you should get full coverage with the epoxy compound. If you're using epoxy mortar application, you first want to put a layer of the neat epoxy as a bonding coat, and while it's still tacky, then you put the mortar. You follow this procedure for multiple lifts, and you don't need to worry about moist curing, but you do need to be mindful of temperatures. So here is the final product of that spall repair. It doesn't have a very clean finish, as you can see, because ideally you don't want visibility greater than 25 feet. The trouble with minor spalls is that they typically get overlooked until they become intermediate spalls. So you want to take care of these while it's relatively inexpensive to do so. So that brings us to intermediate spalls. For these type of repairs, the recommendation is for proprietary bagged concrete. And now I'm going to tell you something that kind of blew my mind. And that is that compressive strengths that are higher do not necessarily equate to a better patch. In the field, I've had construction operations, and the contractor will come and bring a mix and says, we're going to use this. It reaches 5,000 PSI in 2 hours. And I'm thinking, wow, that's great. This is going to be a great repair. But no, that's not actually the case. The best practice is to select a non-rapid setting material with the lower compressive strength, and that'll give you the best long-term performance. And this is DMS 4655 for concrete repair materials. And that's going to give you, again, the properties, the pre-qualifications, and repair types A through D. Intermediate spalls fall under type A repairs, 3 or 4, depending on the location of the repair and the thickness. Again, it'll take you right over to the material producers list where you can find pre-approved manufacturers. So this is, now that we have our materials, we're going to move on to the surface preparation. And that's really the same as the minor spall procedure, except now we're dealing with reinforcing steel. And the manual gives you really good guidance on how to get clearance around the bars so your repair material can flow through, and what to do when you're dealing with rust. That's when you want to abrasive blasting to remove it from the surface. And just be really careful if you're working with pre-stressing strands. You want to saw cut the patch to eliminate the feathered edges, and you want to use, again, handheld grinders or saws to square it up. And always roughen the substrate so you can improve the bond. Using mechanical ties that bind the parent material and the repair material is going to improve the repair. You can use stainless steel expansion anchors, or you can use dowels with structural epoxy, and the manual covers the installation of both types. This is an irrigation canal on FM 471. We had a lot of debris and contaminants that were running through the canal that did a lot of damage to the concrete. So we have intermediate spalls, we have some minor spalls, and it was over all of the columns. So we put together some sheets where we decided to go ahead and install dowels with epoxy and add a cage of reinforcing steel and come back with 3,600 PSI concrete. So this is some pictures of the guys working on them. You can see them drilling and epoxying. I think we did it at 12-inch spacing. And we were lucky that there wasn't any damage to the pre-stressing strands. It was mostly the outer cage that had the damage, and it had a lot of rust. So then they put in the spiral cage and some additional bars.
How did y'all get that spiral on there?
Yeah, they put it through like a key ring. I know. It took a lot of work.
Like taking a slinky and
Exactly, I know.
turning it on.
So next we have mixing of the bagged concrete. If it's smaller applications, you can just use a low-speed drill and a jiffy paddle. But again, don't estimate, follow the manufacturer's instructions. But if you have more than 1 cubic yard, you need a plan for that. You can use volumetric mixers or mortar mixers with approval. And keep in mind, though, that they have short working times, and you don't want to overmix. So temperature ranges are provided in the manual, and you want to apply the material over saturated surface dry substrate. And you can achieve this by ponding water, which we don't always have the time to do that, or you can high pressure water blast for a few minutes, which is what we did here. And then when you're applying the concrete, you can either do a trowel application, which starts with a scrub coat, followed by application of the material in lifts, and you're roughening and wetting after each lift. But you can't use any aggregate with that method. So you also have the form and pour method, which is what we opted for on 471. And we consolidated the material by vibration. So curing is really important to the long-term success of your repair. You want to avoid shrinkage cracks, so cure for 72 hours. If you're form and pouring, you can leave the forms on for 72 hours. And then finish and blend so that it resembles the surrounding concrete. See, so we have these nice, big, beautiful columns where there was some sad piling there before. Okay, so next that brings us to major spalls. And we see quite a bit of this in railing damage, bridge hits. And this is a picture of a deck and rail that was damaged, another major rail damage, and this was another bridge where a car flipped over and hit the column, and this one was also more severe. For these kind of repairs, we want to use batch concrete just because it's good to match the existing concrete, and also you're dealing with more cubic yards. And the repair method is the same as the intermediate. I mean, you're following the manual. It's telling you about the surface preparation, which we talked about, mixing, application of the concrete. You can, of course, use epoxy anchors or the dowels whenever you decide that that's needed, and you can add reinforcing steel when required, and you're forming and curing per the manual and the specification. Batch concrete, like I said, is used for major spalls, and we do that in accordance with TxDOT specifications. The nice thing about this manual is that it complements the standard specifications with TxDOT. So this is what you don't want to end up with, is a failure at the bond line. You don't want to have to come back and deal with maintenance issues, and this is the most common type of failure that occurs, and that's because of stresses that develop due to loading or differential thermal expansion and contraction at the joint. We go faster now. So that brings us to bridge deck repairs. So we finished Spalls, right? It was minor, intermediate, and major, and the 3 repair procedures. Now we have bridge deck repairs, and these are classified a little bit differently. They're classified by depth and speed. This is a partial deck repair, at least we think it is, but when you get down to chipping it, it may become a full depth repair. Then we have deck repairs over precast panels. When you have this situation, you want to remove the concrete to the top of the panel. Next, we have full depth repairs, and we've seen a lot of these in the past year in the southern part of our district because in the energy sector truck volumes. You can see where they tried to put cold mix in the hole, and it didn't work, and it just kept falling through. And it didn't last at all, I mean, not even overnight. And you could see straight down to the river through this hole. So it's pretty major. Which brings us to the next kind of classification, which is by speed. And that comes from an immediate need to return to surface, which was definitely the case on those last two structures because they were two-lane highways. And that's most often the case with this kind of failures. So they classify it by 4 hours, which is type B, which is an ultra rapid repair. And then there's 8 hours, which is type A, and that is also a rapid repair. Then we have class K, which is 24 hours, and class S, which is 2 to 4 days. Class S would be your best bet. I mean, but we don't always have that luxury. So you want to avoid damaging the sound concrete when you're cutting back and breaking back. 30-pound hammers can be used for the bulk of the work, but you want to use 15-pound hammers at the base and at the perimeter. Keep the repair area uniform and avoid damaging the existing reinforcing steel when you're using the saws. Again, keep it clean the substrate, clean the reinforcing steel, and achieve SSD by water blasting. If you need additional reinforcing steel, make sure that you follow minimum spacing and minimum lap lengths, and you can bend and secure the reinforcing steel as needed. And this guide works really well with item 422 concrete superstructures for placement and for forming. You can see that some repairs turn out better than others, and that's, well, moist curing is kind of often neglected due to time constraints, and that can be problematic in the future. You want to cure as long as possible. Even a couple of hours can make a big difference, but 72 hours is the ideal. And this is what you don't want. Here's an example of an improper deck repair. This manual is going to help you select the method and the materials that are going to give you the best results and give you confidence that you're going to have a long-term results, and you want to avoid future maintenance issues. So I couldn't cover everything in the manual because there's so much and it's so awesome, but there's also crack repairs for pressure injected epoxy, gravity fed epoxy, surface sealing, voids due to honeycombing is covered in there, damage over traffic, piling repairs, and that's post fabrication and when you're driving the piling, making and patching cores, and finally trimming or cutting pre-stressed concrete girder ends. That happened to me once like 5 years ago, and I wish this manual would have existed back then. I wouldn't have freaked out so much. And then finally, thank you. Thank you to Bonnie Longley, our San Antonio Bridge engineer, because she let me present on a topic that I find really interesting. And James Muth and the San Antonio Bridge crew, because they take a picture of all their repairs, the good, the bad, and the ugly, and they let us know what works and what doesn't. And thank you to Graham Bettis for creating this amazing manual. I'm a big fan. And thank you all for listening.